get started. Today, we'll talk about top 5 ways to manage a hybrid container and VM environment from a resiliency perspective. There are 15 other ways or 200 other ways to manage an environment that comprises of container and VM. And it could be, when I say environment, it could be multiple external services focused environment. But what we are approaching this problem is purely from resiliency perspective. And we cannot obviously talk about 200 other ways. We'll talk about what are the top 5 ways, and particularly in those top 5 ways, we'll drill into one particular area, and then we'll explain how you could potentially manage your complex environments that are growing in nature using containers as well as VMs in the backend. I am Govind Rangasamy, CEO and founder of the company. We have been doing a number of webinars on the application resiliency side. So if you have some time to kill, you could go to our YouTube channel to view all the recorded webinars in the past. We have been doing that for almost close to 2 years now, as well as we keep announcing the recorded webinars and the newer ones on our social media. So when you get a chance to dial into our future meetings as well, we would really appreciate. Having said that, this will also be recorded for you to refer or even forward to other members of your team if they are interested or they might be interested. All right, so what Gartner is saying is that by 2022, in a couple of years, more than 75% of global organizations will be running containers in some form or the other in production. Like, this is the key thing. We got started with containers back in 2014, and particularly with Kubernetes at the end of 2014. Our entire team started with that, and Kubernetes was like 0.9. It just came out of Google about 6 months or so. Then we got our teeth into how this new system really works. And my background going back to private clouds at Eucalyptus, I know the difficulties of putting together some kind of a cloud type of platform that mimics the public cloud, that automatically schedules and scales and making it easier for application developers to release applications into production the way they want it. And it's still going on. This is a huge change. The private cloud environment started with virtualization based on VMs, and containers really revolutionized a way to package and virtualize applications. And that has become and proven to be one of the, I would even go to the extent of saying it's a revolution in terms of how we package and run and we deploy and run our applications in production. And on the, with any newer technologies, there is always the byproducts that we didn't expect or the innovations that were waiting for the new platforms to take hold. And from that point of view, the microservices approach of distributing the application, separation of concerns, have also started evolving, and the containers pretty much became the foundation for creating such environments. On top of that, once you have a lot of containers, then you needed an approach to running and managing them, maybe automating them in the backend. That is why Kubernetes has become one of the key de facto orchestration engines for running these containers. So overall, containers are here to stay, and Kubernetes is the de facto standard. Now we are taking the next step. So assuming that more and more applications will be running on the containers going forward, and more and more applications will be microservice or more distributed in nature and more dynamic in nature, and maybe portable between the cloud platforms, this evolution is just getting started. And With that in mind, when you think about an application environment consisting of multiple microservices, or even you could say macro services in running on the container package, if you will, and scheduled by Kubernetes to run on specific nodes. If you think about, looking at the application environment as a whole, containers alone and the Kubernetes environments alone are not standing in isolation. They are, in essence, making use of other services, other cloud services in an environment. In particular, we'll talk about, how an example application like SockShop, which is a typical open source container application that's being used to demonstrate the capabilities of Kubernetes and containers. We'll take that as an example and explain how the entire, architecture of one of those distributed applications relying on an external service or a set of external services could be created in such a way that they can be completely resilient, and we'll examine those ways as well. So keep in mind that this particular webinar is about VMs as well as containers, not individual components. We are not going to talk about how to back up and recover just containers alone for resiliency purposes or VMs backing up and recovery. It's about the entire application environment made up of multiple services and predominantly the stateless components running on the Kubernetes environment. Having said that, there's always another set of requirements come in. When you try to run these distributed applications, the attack surface automatically increases. You are distributing the applications across many different nodes and potentially to different zones as well. Zones within the cloud platforms are completely different data centers. And our demo application will also show you how those different nodes are distributed across different zones as well. And having said that, cyber resilience needs an entire environment recovery. So you could look at from a resiliency perspective, particularly from a cyber resilience perspective. The reason for that, too many to even specify, but you could see some of the examples. The attacks are increasing day by day. The recoveries are becoming expensive. And when you distribute the applications more and more across many different microservices and platforms like Kubernetes could be very, very simple or could be really, really complex type of environment. When you have that kind of environment, how would you recover from a ransomware attack as one of the reasons why you need to really think about resilience for your application environment. Now, some might argue, and this was the case before, not necessarily now, that when you move to the cloud provider is responsible for example, protecting your applications. I'm not talking from a security perspective. I'm purely talking from resiliency, application resiliency from backup and recovery perspective alone. I guess resilience overall, it's a very large topic. We may not be able to cover everything in this particular webinar. Having said that, Gartner has been getting a lot of inquiries around, hey, we have made the choice to go to the cloud, and we may be utilizing the containers or the newer services that are becoming available, and cloud providers are making it easier every day for us to consume those services. If that's the case, who is going to be responsible for the resiliency aspect of those containers? And Gartner is also saying that the root cause of 90% of the cloud-based availability issues are because people are not taking advantage of the cloud native functionality available, right? And that is why a lot of organizations are thinking about, hey, when we were in the data center, we used to use backup and disaster recovery system for a long time. And now that we have shifted over to the cloud, maybe we should look at newer solutions or cloud native solutions and so on. So that is one of the aspects that I kind of highlight when it comes down to how you look at the resiliency overall. And I also throw these slides. You don't have to take it as is, it is our point of view, but it is also highlighting one of the situations that are happening in the market today, especially when you come from a data center world. And if you're trying to become cloud native environment for your applications, and when you think about protecting that environment for resiliency purposes, you cannot think about like 5 different ways of doing that. It's very difficult to think about backing up the VMs and even individual databases and restoring them. That is certainly a use case that was great. And now the container-specific protection environments are coming up, or services coming up. And you cannot get rid of the old if you're running still in the data center world. You cannot get rid of the host-based application because there are too many storage systems to go after, and so on. So there are n number of ways to complicate the application resilience. Not only the different sets of tools, but also time, effort, and the manual errors that you will end up going through to achieve this. How to achieve application resilience. In fact, people have given up. We have simplified it to a point where it is, couple of clicks. When you consider your application environment consisting of both containers as well as your virtual machine-based environments, right? You could use it for multiple purposes, but we are talking about resiliency. And in that, in that discussion, particularly when you think about an environment, it's VMs and containers as well as cloud RDS systems and all other cloud infrastructure as service instances. It could be load balancers, VPCs, routes, all of that. Now you have to really think about, in order to really bring that thing out in terms of resilience, in terms of really recovering the systems, you will have to think about all these moving parts, right? And when you think about that, let me point out some of these issues that a typical enterprise, and we have worked with a number of enterprise customers that have gone through this journey, and they say it has become so complex for them to manage the backup and restore infrastructure. So when you buy a product, you will have to install and manage, upgrade, and then also make sure that that protection system is running in a highly available manner. So if you lifted and shifted, as an example, before containerizing your environment, and you also took your legacy backup, protection system with it, vendor system with it, now you're running in one of the zones of the region of a particular cloud provider, right? You are responsible for managing that environment. Second, you will end up putting a lot of agents all over the place. And think about the situation where you have agents running on the nodes or on the VMs that are scheduled to auto scale based on the load balancer configurations. Can you think of ways to manage it when you don't know when those systems will be triggered and come online? And on top of that, these systems will end up using the same network that the production environments will end up using, meaning your applications will use the same network as the backup environments, backup protection systems, pulling the data out of those environments as well. So there is additional network congestion because you cannot dedicate a dedicated network card and set of ports to route your backup traffic over to a data management environment on the side. And we talked about this VM and container backup systems being completely different because container backup systems are newer, right? And some even question, do we really need a container backup, especially when you have a registry and a DevOps pipeline that knows exactly when to deploy with respect to the pipeline versions that you could pull and deploy all the stateless components at a particular point in time, anywhere it runs. So if that is the case, do you really need that container backup system? Unless you have your stateful components, and then you will have to really think about how to manage those. and think about all the storage lifecycle in the backend. And on top of that, when you move to the cloud, infrastructure as code is the default mechanism for you to manage your application environment. If you start with a traditional legacy approach of, hey, I can create a virtual machine or even a set of virtual machines or resources for that matter through some kind of a support ticket system, you are too late, because when you try to create one of those and also configure auto scaling, you're already confusing the application environment. It becomes really, really difficult to manage. And on top of that, think about this situation where your data is taken into a third-party data management system where it gets locked up, which means that any data that gets pulled from your environment is getting translated in some form. The newer systems are kind of better, but in any case, you are translating it. You are not really taking the raw format. As an example, if you capture through an agent an NTFS system, NTFS-based application that is running in the background, now if you converted using a proprietary data management vendor, they will have to support not only NTFS, but also all other file systems in the same data management engine. If that's the case, there is no other way other than putting a common mechanism for managing all the file systems. That is when the translation happens. That is actually a killer with respect to an RPO and also with respect to an RTO. And that's when we ask this very simple question. Do you have your applications fully protected? And we say, by the way, when you think about the entire application environment, based on our analysis, based on the number of resources that we have seen our customer environments running 370 to 400 virtual machines, we have about 12% of that application environment protected, roughly, because they only protect these VMs or particular databases, not the entire environment and also the cloud resources. And that's when you have to really think, what other ways can I do this, right? And that is where we have put in this important notion that there are so many ways, but what are the top ways that you could really create resilience for your applications? And there are multiple ways of doing this. There is an active setup that you could do, meaning that, by the way, this presentation assumes that you have moved to the cloud platform. I wouldn't advise you to try out all these capabilities, even if you're trying through Appranix or some other means. I would recommend that use a cloud platform to protect your environment. And also the conversation that I'm talking about is all based on a cloud environment, be it AWS, Azure, or Google Cloud. So having said that, you could configure your infrastructure in multiple ways to create the resiliency that you want. One approach is active setup, meaning you spread out your distributed application running on Kubernetes and also the VMs across multiple zones in the same region. It could be 3+ zones. We have seen a customer running 4 different zones as single application, enterprise application using RDS. So that is one way to structure and achieve resiliency. Another approach is active warm. I call this active warm because a pilot light system is running in the second zone, whereas your primary zone is running your production environment. If that's the case, then if there is a problem, you could pretty much shift your production workload over to another zone where the environment is kind of warmed up. I would call it a pilot light type of situation. Third is multi-region active-active. So you assume that the same region, everything is running okay. Now you want to stretch your resiliency some more, and in that case, you could think about, what if I could do active-active? Again, I wouldn't recommend you to try the active-active between US East and West, because there's always a latency, and one of our customers tried it and it wasn't successful. Again, depends on your application workload, type of architecture, and so on. There are so many variables here in play. However, you could try this architecture between central region and the East Coast. Most of these cloud vendors have some form of central region, Ohio-based regions, and the East Coast, Virginia-based regions. You could have a setup, multi-region setup that is active-active, and you could spread out your federated Kubernetes cluster between these two regions, and also have a mechanism for the databases to have free replicas on the other side. Or if you have cluster databases, you could structure in such a way that the load is automatically switched over at the stateless container level, but on the database level, asynchronous replication will help you in terms of achieving a much better RPO. So I wouldn't waste money or time or set up all these complex setups unless it's absolutely required. But this is one of the approaches you could take. And moving on to the next one, probably a practical approach, is that you could have a multi-region active warm setup, whereas the RPO for your organization should be palatable in that sense that if you could tolerate a 5 minutes type of downtime, or data loss of 5 minutes or 15 minutes, depending on the situation, right? In those situations, I would say a very practical middle ground, rather, because when you try to run multi-region active-active, you're also spending double the amount of cost on both sides. So you could have a pilot light in the second region, protecting again a single region failure, and you could have the databases kind of reflected on the second region, or you could simply shift the entire database over to the other region, as we will show you in our demo case, so that you can bring up the entire environment in under 10 minutes, depending on the type of application and the complexity, of course. Stretching it further, you could achieve real protection beyond just a second region. You can also push it to third region or even 3+ regions if you're really, really concerned about what if this region fails, and what if an entire domain account has been taken over by a ransomware. Now what am I supposed to do? If only I could have another region with a completely isolated domain and a cloud account, or maybe a project, I could potentially shift my entire application over to another project coming through a different domain that the ransomware did not attack. That is another way to deal with it. Having said all of these 5 different ways, and there could be more, but what we have identified for the purpose of this particular discussion is the 5 different ways. And in that way, we will explore and go into this particular multi-region active warm architecture that could be a practical from management complexity perspective, but also cost perspective, right? And having said that, is it too hard? So the question is, how big is my environment? Who is going to first of all manage this environment? If you're an SRE, you'll be really, really concerned about operating all those services that your wonderful development teams are innovating day in, day out, are pushing the newer features. Maybe they are doing a bunch of bug fixes, but still they are updates to your environment, and a single update could potentially take down the system. And sometimes you can have a rollback strategy for a particular microservice. That's a great one if you have proper CI/CD set up. But I'm talking about a system that is completely resilient. Is it too hard to operate such a system? It is not. That's what we are saying. You could pretty much subscribe to Appranix to auto-discover the environment, add the policies that you want with respect to your RPO, or based on your SLIs that you want to really kind of control. And based on that, you could give whatever the SLO that is necessary for your business from an SRE perspective. And from a recovery perspective, it's very easy to recover with a single click. So that's what we have been saying. You can onboard, protect, and recover your applications over a coffee break. And of course, this wonderful, we call it as our signature statement, and we have made it as a signature statement over a period of 2 years now, based on practical application of how our customers are getting onboarded. And we have really tested the situation with the customer. And in fact, one of the environment is directly from a customer environment here. You can see how complex this particular environment is. It's not even involving the containers in the front end. So you'll see this is about 3-zone architecture with multiple load balancer instances with all other configurations within the VPC and external configurations. If this is a part of your application environment, then you can see the complexity that you will have to go through if you have to protect the entire environment for resiliency purposes, right? What is the dependency between two components? How do you know? Because these application environment components keep changing. Newer services are being rolled out. And if you rolled out new services that are connecting externally to other services, providing services to, let's say, your stateless components running on the Kubernetes, how would you control the resiliency in that aspect? And it keeps changing, which means that some system has to continuously understand what's changing every 15 minutes or every hour, so that at a particular point in time, you can pick that entire environment and recover it really, really quickly. Or you could pick up one particular instance and recover in the same region if you wanted to, right? Within the same zone if you wanted to. So all those flexibilities are very, very important. So if you think about the picture that I showed you before, like 5 different systems, and having the complexity for yourself, your own teams to manage, it becomes humanly impossible. I would say impossible, really, really hard to manage that environment. And even with that, you would think, so I have somehow put together a kind of a resilience system, maybe homegrown, based on some snapshots and so on. Now it comes down to, am I really sure? It's almost like the COVID situation, right? Sorry to bring that dark days of things that are happening, but it feels something like that. Unless I tested, I'm not sure. I have the antibodies. I'm not sure I'm resilient or not, right? And should I go and test? Is it going to be costly, or is it going to be available to begin with? Is it going to take time? I don't know. Is the test available at all? Similar to that, if you put together your own resilience system, then you'll have to really think about, how am I going to test this? Is one test sufficient, or is it going to be like I can configure something so that the test could be run frequently or whenever I need it, or maybe a period of time is every quarter, every month, maybe every 6 months, even every year? How is it going to be? And that's when people ask all kinds of questions. So do I have time, right? Is it going to be easy? Teams are busy anyways with production environment work, right? And in the olden days, recovery tests are almost like a project. You will have to schedule with your resiliency provider, be it SunGard or IBM Resiliency Services. They need to understand what's your latest configuration is. The systems today may not even have the capability to understand what is the size of the VM that you configured like yesterday, right? You'll have to maybe file a support ticket for resiliency provider to take the latest information over to their environment so that they can fix it. And is there a guarantee that your VMware environment with 6.x, maybe 7.x now, compatible with the service provider VMware environment? Is a network compatible? They might be running a different network infrastructure completely. So setting aside the data center complexity, even moving over to the cloud, the same set of questions come in, even though the problems are little less in terms of putting together the environment. You may be taking snapshots of your entire workloads in an environment. Maybe you automated with some kind of a policy management engine. But what happens to other environments? What is the cost of the kind of a testing that you will have to do to make sure that the systems are resilient? And I'm not going to even walk through the skill shortage. How many people have real practical experience and the certification on a particular cloud provider to help you to achieve the resiliency that you want, right? And that is where a platform like Pranix really helps, because you could pretty much add a simulation policy that will automatically run the system completely for you, right? So what we are saying is that backup is key, absolutely key, and that is taken for granted. That is table stakes, right? You will have to have a mechanism to backup, maybe snapshot, maybe some kind of a backup mechanism that you took it from your data center days, and you are trying to kind of use the same mechanism for your containers. Totally fine, absolutely great starting point. But what we are saying is that you could push it. You could really achieve a much better resilience with a system that are with the newer systems like Pranix that are completely SaaS, that are application centric. You could run containers, VMs, cloud databases, self-managed or outsourced, run and managed by the cloud providers, and it's all cloud native. And we encourage you to take advantage of the cloud native solutions available, all software defined. They are resilient from an infrastructure perspective, and the cloud providers are telling you to take advantage of it. Not many organizations really take advantage of it. If you took advantage of that, you could literally reduce your RPOs and drastically could be potentially reducing your RTOs as well. And that will give you confidence that your applications could achieve much better resilience. And that's why we are giving backup for free, right? We don't charge for the backup. It's all about the entire protection of your application environment, and you could run as many recovery tests as you like. Of course, please keep in mind that when you run those recovery tests, some of your PERS will be affected because you might be spinning up the instances in the other region as well. A number of our customers have gone through this. Enterprise customers, right? One of the financial services side, another one is on the EdTech side. They've all achieved a much better resilience compared to what they had before, right? Of course, they are backing up and they can recover it anytime. So underneath all of that, there is a sophisticated system that we run, and it runs on the cloud. And Pranix is an account on a Pranix Resiliency service, right? And when you discover your environment, you will discover all the services, and Pranix will take care of learning from your environment continuously. We do not take your application data. Your application data stays in your own cloud account. And that's one of the main reasons you do not incur the lock-in that you'll end up getting like other data management systems. Your application data is native. It's one of the reasons why RTOs could be much better. RTOs could be drastically better, right? And you can pick up at any point in time and bring up your entire application environment. And like I said, there are ways to achieve multiple levels of resiliency. Having said that, let's jump into the demo. I'm noticing the clock, so I'm cutting down this particular aspect of it. You could integrate the resilience into your pipeline, call it as continuous resilience to achieve. And you can also use it for multiple use cases as well, not only the use case that I just talked about, but other use cases as well. So you're free to leverage the capability of the systems. So having said that, let's go through a demo. So the demo consists of multiple tabs. Multiple tabs. I am going to make sure that you don't get confused, because I am trying to demonstrate a distributed system. And let's start with that application. So the application looks very simple, where you could go and buy socks, broken socks, if you will, right? And that will only cost $100. I'm not sure, if you feel really comfy, if you really want that socks, go ahead and buy it. I am not going to ship it. I do not have a prime mechanism to ship you the, torn socks, by the way. So anyway, this application, a wonderful application, runs. It looks very innocent, very simple website. But on the other hand, it is a very complex environment. And if you think about that environment, let's refresh it. This environment will keep changing as I click here. So it's very dynamic in terms of how it spins up more parts and services and so on. So you can see the services will, all the namespaces. Let's look at the sock shop ones, and the parts will start. So you can see the catalog services, a bunch of containers are running here, and you can also go into image or in terms of complexity of how this application runs and scales. So these are multiple nodes, I would say parts that are scaling depending on how the application comes up. So the more activities you do here, you can see live action happening right here, depending on what you do. It's very, very live environment. So this is your application, and this application runs on the East Coast of Google Cloud. So you can see the backend of that application is running on a bunch of virtual machines, running the databases, CardDB, OrderDB, and UserDB. And there is another database running on the Cloud SQL side. And the front end of the application runs on the GKE engine. So you can see all the workloads on one of the clusters here. So this is a Kubernetes engine hosted on the East Coast. And this cluster hosts all the stateless component of this application. You can see the number of parts, and Kubernetes is configured to automatically scale depending on the workload that gets thrown into from this application point of view. And the DR environment that we will fail over is hosted on the East Coast here. So, so the production runs on the central region. If I mentioned as East Coast, I'm sorry. This is the production runs on the central region, and the DR environment is going to be failed over to East Coast region of Google Cloud running GKE. And the container environment, the virtual machine environment here is running on a bunch of virtual machines as well as a Cloud SQL, which we will discover. So when you get started with Appranix, it's very simple. You can type in here Appranix, and you will find Cloud Application Resilience, or we listed as Cloud Application Resilience for Kubernetes. You can find it on the marketplace and subscribe to it. It's very, very straightforward, assuming that you have created an account. And let's see if it's running. I didn't have to log in again. So we'll start off with the container resilience. So I have separated the container resilience and cloud resilience. Cloud resilience is basically for the virtual machines and Cloud SQL. We call it an external assembly. That is the hybrid nature of this application. And container resilience running the sock shop application here. Our notion of representing your environment is called assemblies. So the assembly has all your workloads, and you can see this front-end stateless assembly, container assembly, which is being run here. And this is the actual running instances, runtime of your application, the demo application that I'm showing here right now. It's very, very dynamic, so it keeps changing depending on how we throw in the workloads. So having said that, when you configure your policies, you could configure, hourly policy here. And the external service assembly is right here, sock shop databases, and that will point to the cloud resilience where the resources are automatically identified, discovered. You can see the number of instances here, 3 instances running the sock shop databases, and Cloud SQL running a component of that application hosting the portal component, portal transactions, and so on the Cloud SQL side. And the policies, you are not configuring the policies here. The policies are directly coming from the policies that you have configured for your application environment from a stateless component perspective. Everything else is automatically taken care of. And when I talked about application environment time machine, this is your application environment time machine where the policies are capturing your environment. I have a much better view here. If you look at the timeline on the external assembly side, you can see for every hour configured through the Kubernetes, stateless component environment, you are capturing all the configurations, all the data from Cloud SQL as well as the virtual machines that are hosting the SOC shop databases. You'll see all your audit logs. You can cut and paste if you have to submit some kind of an audit history here. And also the recovery. When we fire the recovery, you will see how the recovery is being done. So this is what we call as application environment time machine, because it is capturing the entire environment. It's not capturing your individual instances, and it's capturing at a particular point in time. So you could even, in fact, go and get the firewalls recovered, right? So you don't have to worry about a particular instance of a particular cloud resource. And having said that, what we are going to do, we are going to take down this particular application. Here, I have a couple of scripts to kind of make it easier for me to show you from demo perspective. I am going to fire up something called a disaster script. And I have to just make sure that I have the permission. It looks like I'm root, so I'm going to just fire off that disaster script. What's going to do is it's going to take down the Kubernetes environment slowly. So you can see when the parts are taken out, they are being scaled back. So if you go to the Kubernetes running on the central region, you can see there are parts that are running here. So you can see when the parts are getting killed, these will all become zeros. You know, we are taking away the parts, which means that we are taking away, we're simulating disaster here to an extent. And the application will start going down as well. Let's see if refresh. It has gone down, so you cannot really browse. You know, the databases are kind of being dismantled to an extent from the access. And the environment, as you can see, it has reduced a lot. You do not see the front end is kind of running right now, but it will go down anyway when the workloads kind of disappear. Let's see. There you go. So it's disappearing now. So what we have done is that we have simulated a mechanism for the disaster. Now what we are going to do is to roll this environment over to the East Coast. So what all we have to do, if you look at the Kubernetes cluster connections here, we have configured the production cluster as well as the DR cluster. That's a point that I made initially. It's an active warm setup. So the GKE engine is primed, but it has nothing other than the basic system environment. So the GKE environment, if you look at it, it's having only the basic minimum necessary. AX represents Apranix. So you have some daemons or controllers running already primed to be ready so that you can fail over your application environment. So what we are going to do, we are going to take that container assembly that is called shop. We access a particular timeline, and we are going to recover at this particular point in time, 1 o'clock. So here, say recover and select the DR cluster, include the external service to recover as well, which means that all those VMs that are running in the central region need to fail over to the East Coast as well. So the recovery region here is the East Coast. So I'm picking the East Coast recovery region. That's it. The cluster is going to be the DR cluster, and obviously it will become the production environment running cluster, and the recovery region will have all other external assembly services, which are the entire thing that I showed you from cloud resilience perspective, and recover that entire environment. Now, when you fire that, that is the only click that you did, right? It's going to do a lot of work for you. You don't have to worry about, again, thinking about the configuration of all your application environments, right? This is the external assembly that will be recovered at a particular point in time. And if you look at the backend, the recovery for that particular point in time has already started. So if you think about it, I am recovering this particular 2020-07-17 at that particular point in time, or an hour ago, and the recovery details are here. So if you look at the recovery resources, it's firing up all these resources to be created using infrastructure as code. that infrastructure's code is native to your cloud. You could be running on AWS with CloudFormation, or it could be running on GCP with the deployment manager. Appranix takes care of all those complexities. It takes care of all that manual work. You don't have to touch your keyboard to code anything here, because even if you try to code, you do not know how the snapshots are going to be lined up with your environment, with all the configurations. In fact, the code that you will end up writing, if you were to, it will be for a simple environment like this. We do not have like 200 virtual machine or 1,000 virtual machine environment here. We are only looking at 3 virtual machine based environment with a cloud SQL, right? And if you think about it, the amount of coding that you will have to do, right? Even for this is a ton. And even if I make a single mistake here, and I configured a VM firewall and it is something else, who is going to QA this environment? That is why you have to leave it to the machines, because the machine can continuously learn and adapt based on what's happening in your production environment, right? So this is the type of capability that we have created, particularly to help organizations to achieve that resilience, right? It is not a backup. In fact, backup could be free. If you're already paying for the cloud provider snapshots, why do you have to pay for the backup as well? Right? All you have to worry about is the recovery of your environment, entire environment to be specific. If that is entire environment, then you will have to really think about, oh, am I going to code? Even if I'm ready to code, then I should know how GCP behaves. And even if you did one of those coding, then you will have to adapt to all the changes that GCP team has been releasing over a period of time. They are holding their virtual GCP Next conference now as we speak, and they are rolling out a ton of new features, unbelievable number of features being rolled out as we speak. And those capabilities could be leveraged for your application environment. So if you think about it, you didn't have to touch your coding prowess, if you will. Yes, you could code. You could certainly do all of that. But would you be coding something that is so far more important for your business as opposed to worrying about the infrastructure that hosts your application, right? That is the biggest question that you will have to answer. Now, let's see if the recovery is complete. The recovery, Cloud SQL takes a bit longer because it's not only recreating that particular instance of the Cloud SQL, but also we need to make sure that the data is recovered as well. Having said that, you can always have recovery logs. While this is being recovered, I will also highlight one more area that you could make use of. That area is recovery simulation policy. I mentioned about the recovery simulation capability where you can pretty much let Appranix taking care of the recovery test activities for you. So you could say, recover my environment, my container and VM hybrid environment, right? I call it as test. And I could say, I could test it even daily if I wanted to, because the recovery time is going to be less than 10 minutes for my application. Of course, your applications could be so different, so complex. And depending on the situation, I could do a monthly test, or you could do a weekly test, depending on your situation. We are not even putting a yearly test here. We are encouraging you to test. So we talked about yearly test. We said, encourage people to run this test. Do a weekly test if you could do. And then you could actually, you could do multiples of those as well, right? Why stop at one? You could have multiple, frequencies, and you could also specify when you want this test to be run. 12 o'clock in the middle of the night, right? That's great. And you choose your time zone. You could also do preemptible recovery profile, which means that you, instead of using the classic instances that might cost you more in certain situations, you could do preemptible spot instances as well. And you specify the region where you want to recover. And you could also say that you could make use of the successful or partial timeline items as well. And the system will try the first one. If it fails, it will try the next one. If that fails, it will try the third one, and then it will give up. You can also say that reset the entire environment, because now you have created all the resources. You need to clean up, put that environment back so that you don't get charged for those. All you have to do is to save this, and the system will automatically take care of running this test every month. Of course, I don't want to configure this one, so I'm going to disable it for the demo purposes. You can also edit, delete, or disable. Typically, I kind of disable until I wanted to show the capability. Now, having said that, you can go and explore. If you have been running your recovery test or protection test, you can get to know what all the environments, everything is protected properly or not, and if you have to send this off to any auditors and so on, you have complete detail here, right? Even the elapsed ones, all the protected environments, you have all the details that you could send as a recovery. So you can go back in time, July 1st as an example here. You can get all the information from that particular point in time. So all the details of what it is, take a screenshot or export it and do it. I haven't done a lot of recoveries, simulations, so you won't see much of that. I don't even know when I configured. I think I disabled it, so you won't see a lot of that recovery resilience. Now, let's take a look at what's happening in our environment. I think its deployment is complete. So on the by account, we just completed. And if you go back and look at the environment and timeline, and recovery is still in progress. I think it's the last one. From the logs perspective, we should know. I think the Cloud SQL apparently takes a little bit of time from the deployment manager to sync up, putting the final touches to make sure that this application is ready to go. There's a little bit of activity here. I think deployment manager says it's done, but we want to make sure that the SQL server is actually ready to go. So unless it's ready, we won't mark it as recovery completed. So having said that, since a partial environment is already running, we could pretty much fail over to the other environment and let the database come and connect itself. Because by the time we wire things, Cloud SQL will have been recovered, and the data anyways is through the snapshot, so it should come back again. So what we will do, we will run the recovery script. In this particular case, what we are doing is that it's already working on the DRGK cluster, and it is scaling that environment for you automatically. So if you go to the DR environment, you see here, it's only few, and let's refresh it. You will see the entire environment has failed over. So you can see the front end of the application that's running now in the on the East Coast, and it's catching up in terms of the connectivity to other components of the application environment. So once all these configurations, is basically what we are doing is that we are scaling the cluster. We are first of all connecting the DNS appropriately, failing over the DNS to make sure that everything is okay, and then making sure that the YAML Kubernetes YAML files are properly configured so that Kubernetes GK engine automatically scales that backend. Now let's look at what's happening. If it catches up, the DNS has to catch up. There you go. The application is back, and since the DNS is set up properly, that application will be up and running. It's checking a few other things, and luckily the application is back again. And if you look at the parts here, it will catch up as well. Sock shop wasn't there. Since the DNS has failed over, let's see if it comes back. And meanwhile, the backend for the Cloud SQL should be ready as well. It is ready. The recovery is complete. The Cloud SQL environment is ready as well. So all of that is ready to go, and your environment is running. Application is running. The backend of that should catch up really quick. So it's coming back, and look at the sock shop nodes. It will be configured and it will be running quickly here. The namespace will be shown. Let's do a refresh. Sometimes what happens is that the DR environment, my cache in the browser creates problems. But what is important is the application is running here, and looks like the application is configured to run. So given that, what we have done is that we have failed over the entire application with a click of a button, right? And also made sure that your external assembly has been failed over as well with a click of a button again, right? And all you have to do is to make sure that your application runs. And once you're satisfied, you could say, schedule the reset, or you could do the reset here. So you could say, delete it, and the entire backend will be deleted. And of course, your application will stop working now unless you failed over. We could do the reset to go back. Let me stop here. I'm looking at the clock and see if there are questions from anyone. Other questions that you had in mind? All right. So anyway, thank you for joining. If you joined very late, really appreciate the time. And like I mentioned, the entire webinar will be recorded and distributed on the YouTube so that you can share it with your colleagues and others that might be interested. Thank you very much, guys, and have a good night and the rest of the day.